Good evening, sir. My name is Ragini Saishri. I'm from SMK King George V Sudamban. I have been tasked to prepare my career profile. My interest is in aerospace as a research scientist. I hope you don't mind that this interview is recorded. I will upload in YouTube as a link for preview for students. Okay, hi, sir. Please tell us about yourself and introduce yourself.
My name is Thanapal Balakrishnan. I have a Bachelor of Science in Aerospace Engineering and a Master's in Business Administration. I've been a project manager for the past 25 years. I've been working in many different industries: telecommunications, manufacturing, IT, software development, and so forth. So currently, I am the project manager for an ERP and cloud based computing software company.
Okay, sir. What made you choose aerospace engineering?
It's my passion. I first saw the interview by John F. Kennedy in his inaugural speech, where he says that we will put a man in a space by the end of the decade. Then I saw the landing of Neil Armstrong on the moon. So it became my passion to do aerospace engineering. I was fascinated by space travel. So that
Okay,
is
sir.
why I did aerospace engineering.
Okay, sir. Where did you complete your studies?
I did my aerospace engineering in US. Uh, in the university called Embry-Riddle Aeronautical University. It's one of the top 10 universities in aerospace engineering and aviation.
Oh, that's great, sir. What do you enjoy the most as an aerospace engineer?
As an aerospace engineer, you will learn many skills on the way to become an aerospace engineer. One of the skills you will learn is innovation. Okay, you will try to innovate things, new items. You will come up with new designs. So these are the fantastic trend or character it will mold into you by the lecturers is to become an innovator, right? If you notice in the industry today, a lot of non-aviation related inventions is a result of aerospace engineering. For example, FedEx, if you have heard of Federal Express, the courier company, where they scan the barcode. It was designed by an aerospace engineer many moons ago, about 20 years ago, while he was doing aerospace engineering in Embry-Riddle. As your bypass um, for the heart surgeries, it was designed by aerospace engineers. Your Teflon frying pans is a material used in the aerospace industry for heat resistance. So there are a lot of inventions was created by aerospace engineers, and that is what is so great about aerospace engineers. You get to develop, design, innovate, create new things that is used in your day-to-day life as well as in the aviation industry. So these are
Oh,
the traits and characters you will develop as you become aerospace engineer.
wow, that is really fascinating, sir. In
Yes.
your opinion, what are the qualities of an aerospace engineer and why are they so important?
The three kinds of ways to look at a problem. Okay, you can look at the problem within the box, outside the box, without a box. As an aerospace engineer, you will learn very quickly to think, look at a problem from multiple point of views, not just one point of views. Is to get an overview of the problem from different perspectives without any boundaries, any restrictions. That is the most one of the most powerful qualities to have as an aerospace engineer is to try to solve problems
Okay,
simplistically. That means without any difficulties. Okay. For example, if you have watched Apollo 13, the movie,
yes, I watched
there
it.
was a scene in Apollo 13 movie where they have to put square peg in a round hole for the oxygen, cleaning of the oxygen, right? So they came up with very ingenuity connecting points to make a square filter fit into a round hole, round filter. That is ingenuity. That's an aerospace engineer. He doesn't conform to norms, normal thinking. He conforms to thinking outside a box without any boundaries, without any restriction, without any limitations. That, as an aerospace engineer, you will be groomed to be thinking in those mental attitude.
Looks like being an aerospace engineer is not that easy.
It
So,
can be easy, it can be difficult, but it is, as long as you are prepared to dream, as long as you're prepared to, you have to do a lot of sacrifice in terms of your time, in terms of your commitment, in terms of your discipline, right? You, unlike many of your other industries, you don't have time to enjoy the leisure and things like that. You will be spending 24 hours, 7 days in the lab, in the library, doing research, doing creative things, right? But just like as your friends might enjoy a leisure day at the beach, your leisure day comes when you achieve certain things in the laboratory. It could be simple things, small things, but the fact that you accomplish it on your own can give you the same happiness as your friends being at the beach. Yes, it is difficult. It is not easy. A lot of people, like for example, when I was a freshman, about 1,000 students entered this program in Embry-Riddle. Just in 1 month, there was only 500 people left. The 500 others dropped out. When I graduated, only 80 people graduated with me. Those 80 people are the original people that enrolled in aerospace field with me in 1990s. So it is a very difficult field, and along the way, it will test you. As long as you persevere, as long as you put hard work and work smart, plan your work your plan, is the key to being successful in aerospace engineering. Aerospace engineering is one of the most epic, epic point of your career, right? If you become an aerospace engineer, you can work in any field because they have groomed you to have a proper thinking attitude. Every problem, you know how to resolve it. There is analysis and there is gut feel, there is intelligence and there is experiences, right? All these will come about because the to study aerospace engineering is not like any other field where you read books and then you go and write an exam and pass. Aerospace field, there is set of equations, but this equation means nothing to you if you don't apply to a specific problem. So aerospace engineers graduate because they experience every formulas, every equation, every design is experiential learning that leads people to become an aerospace engineer. It's unlike any other fields. Like any other fields, like you just need to study and you can pass the exam, you're victorious. But aerospace engineering is not that. That is why in aerospace engineering, even if you get a C, you are a good engineer because it's very difficult to pass aerospace exams.
correct,
Okay,
sir.
even a C is a celebrating point in a thing. Even an F is a celebrating situation in aerospace field. Why? Because you learn to find out how, like Einstein, not Einstein,
Yes.
sorry, Edison.
Thomas Edison.
Thomas Edison said this when they asked him in an interview. So you found you failed 999 times in trying to discover uh, the incandescent bulb, light bulb. For that, Thomas Alva Edison replied by saying, I found 999 ways not how to create an incandescent light bulb. Because failure is the first step towards acquiring knowledge. And that is the first step towards becoming successful in engineering, in aerospace engineering especially. So in aerospace engineering, failure, it doesn't mean that you have failed. It means you have found another way in not to use to achieve a result. So in engineering, you will learn, in aerospace engineering, you will learn there is no right or wrong, good or bad. You will learn desirable result, not so desirable result. So if you achieve desirable result, fantastic, clap yourself, and then move on to the next problem. But if you achieve not so desirable result, you celebrate also, you celebrate more than you celebrate a desirable result. Why? Because this not so desirable result has now given you possibilities how to create something better. You see? So this is what aerospace engineering is. This is what you learn in aerospace engineering. You just don't learn a bunch of equations. Tell you frankly, I have mastered advanced calculus, differential equations, you name it, but that was not important. The important part of learning all this equation is what, how do you apply that in your day-to-day problem solving situation? How do you invent something? How do you innovate something? How do you create something? That's important. Learning all this is not is good. As they say, knowledge is power, information is wealth. But when you apply knowledge and information, wisdom arises, and that's your end goal, wisdom. And wisdom can only be achieved by experiences, desirable result and not so desirable result combined together give you experiences, and based on these experiences gives you wisdom. Right.
All right,
So these
sir.
are the things you need to understand about aerospace engineering. So it's not difficult, it's very easy. All you need to do is have an open mind. Okay, open mind is the key to being successful as being in aerospace engineering. So the out of 1,500 people who attended my program, or but 1,000 people, sorry, attended. 900 people didn't make it, but the 100 who did it because they have an open mind. They were not willing to quit. They were willing to persevere. These are the qualities you need to have: positive mental attitude. You need to have goals, dreams. You need to dream. Everything in aerospace engineering is a result of people dreaming something unique. So you want to be a scientist in aerospace engineering, you need to be dreaming big. You need to make this dream come true. How do you make this thing come true? You work the plan, plan the work. You must have positive mental attitude. You have to have personal qualities that will ride you over adversities. Adversities and challenges are very good, important to being very successful in being an aerospace engineer, because adversities and challenges grooms you to overcome and find creative solutions to the problem.
All right,
Okay,
sir.
so yes, it is difficult, but it is workable, doable, as long as you're prepared to put in the work, work the plan, plan the work, willing to persevere, willing to put in the hard work, smart work, work smart. All that comes into this picture, and that will propel you to be greater heights of aerospace engineering. To tell you frankly, the first three powerful aerospace engineers in the industry are ladies. You should have read their autobiographies, and they were the one that propelled the first space machine to space. Okay, so they were all mathematicians. Okay, they are all mathematicians that made it big in aerospace fields. How they do it is because they solve the problems. Okay,
Okay, sir. Okay, sir. Okay. So, what type of training do aerospace engineers have to go through?
what do you mean by training? What do you mean by training?
I mean, like, what courses do they have to go through? Like, do they get any training? Like, what do they teach?
For example, the first year they teach you calculus, advanced maths, advanced physics, advanced chemistry, okay? You learn all the basic information of science and maths, but in an advanced level, calculus, trigonometry, algebra, okay? You will
Okay.
learn a lot of problem solving skills, right? That's your fresh first year. Second year, they introduce you to aerospace engineering, but the fundamentals for aerospace industries, which is solids, fluids, and mechanics.
Okay.
Okay, and there is a one other thing which is more important along with these three basic courses. Uh, solids, you know solids, right? It's hard
Yes.
metal. Okay, how does it operate in mediums like fluids, water, air, all these are called fluids. Mechanics, propulsions, all the mechanics that makes a body, solid body, flow through a fluids, which is either air, liquid, gas, any kind of fluids that is considered fluids. But there's a fourth course that is very important, which is also aerodynamics. Aerodynamics is the first introduction class to aerospace engineering. Without undergoing aerodynamics, you cannot master aerospace engineering. So there's two things you must understand about aerospace engineering. There is aeronautics engineering and there is aerospace engineering. Do you know what's the difference?
Aeronautics engineering is for aircraft, and is as aerospace engineering is for rockets.
Okay, so aeronautics engineering is under the gravitational field of the Earth,
Oh, okay.
okay, until the stratosphere,
Okay.
right? Aerospace is beyond the gravitational field of the Earth,
Like
okay?
the
That
rockets and satellites.
rockets, space shuttles, satellites, okay, or any kind of space vehicles that makes use of aeronautics technology to break the gravitational field of the Earth. Okay, that's how the simplistic explanation between these two. So, on your journey to become an aerospace engineer or aerospace scientist, whatever you want to call yourself, you need to master aeronautics. You need to master structure, aerodynamics, jets and propulsions, right? Jets and propulsions is got, you might think it's just a fire coming out of the engine, you need to create an engine, but it's more than that. It has got to do with mathematics, equations, okay? How much fuel to burn, what kind of moment in space, nothing works in motion. Like in the Earth, you have a wheel, but if you look at space shuttle, there is no moving parts because no moving parts is possible in sub-zero condition, right? So
All right.
things like that you need to understand. So under the gravitational field, you can use mechanics to make things work. Your your aircraft, for example, you have your wing flaps, right? That moves, that gives you more lift, and you have propulsion system turbines for your engines that moves, that create propulsion, that sucks air and you flow through the air, right? So there is all kinds of moving item in sub on gravitational field area, but in space there is no medium, there is vacuum. In space is vacuum, so you can't make anything move. So whatever you do in space has to be non-moving mechanics, right? That's how
Okay.
it works in space, right? Displacement of space to achieve distance, right? So how do you displace space to achieve distance and momentum? You have to press gas out, then only you move momentum. So this kind of, so it's a different concept altogether. But to achieve aerospace science, you need to understand aerodynamics, aeronautics. So the first 3 years, you will study everything there is to know about aeronautics, which is aerodynamics, structure, propulsion, jet, all various things, right? So you must understand the difference between subsonic engine, supersonic engine, Concorde. Remember, there was used to be an aircraft called
Yeah,
Concorde,
Concord.
but it's no more in production. It was a supersonic jet. But all what is supersonic? You travel at the speed of sound. That's called supersonic, right? Subsonic means below the speed of sound. So all our 747, 737s, all the current aircraft, Cessna, Piper, all this is subsonic because the engine cannot propel you faster than sound. But aircraft, fighter jets, you heard of MiGs, you have heard of F4s, F14s,
Yes,
F15s. All these are fighter jets. Fighter jets, go at Mach. The speed they measure is Mach. Mach 1, Mach 2, Mach 3. That means they're traveling at the speed of Mach 1 means at the same speed of sound, right? Hypersonic means above the speed of sound. Okay. There are
yes,
more other classifications of speed. Okay, there is light speed, and all that. If you watch the movie Star Trek, Star Wars, and all that,
yeah,
you especially Star Trek, you will learn about warp engines that can travel faster than light or at light speed. Okay, these are all maybe fantasy in the movies, but they are upcoming reality. Okay, you have heard of a lot of programs we have where we have sent rockets to Mars,
yes,
Jupiter's, right? How is it? It took them 2 3 years to reach Mars, for 3 4 years to reach Jupiter's, and so forth. But in the near future, India, China, they are working with what is called what engine is called um, not fusion engine, fission engine, cold fusion engines. This cold fusion engine is something like the warp engines in Star Trek, right? They can travel faster, as fast as light speed, and they can go a greater distance without any fuel. Okay, so these are industries that's coming and up and coming. Researchers going on to this. So who's going to be first, China or India? We don't know yet. During Abdul Kalam was doing a lot of research, we thought India would be the first to achieve that, but maybe now China is here. China might be possible. So, to become an aerospace engineer, scientist, or engineer, or researcher, whatever you want to call, you need to understand aeronautics. Aeronautics meaning structure, fluid, jet and propulsion, aerodynamics, all this. You'll spend about 3 years studying them. You need to master them. Wind tunnel. Wind tunnel is one of the most beautiful class you will ever attend. Wind tunnel meaning it's a tunnel, wind goes around it, and you put a model to find out how it behaves in the flow of air. Or you can do it inside a water tunnel. You can put an aircraft inside the water to find out exactly how is the flow over the body is. Is it smooth flow, or is it turbulent flow, or is it more drag? Drag means friction, or is there more thrust? That means forward movement. So this is all the laboratories you will be attending. You will be doing a lot of materials study. You will study materials. You will study composite. Composite materials is a combination of two different materials together. They are lighter, more durable, and they can absorb up to a very high tension strength. So these are the various classes you will be undergoing. And all these classes can be a research field. You can become a material scientist. Not only can you contribute your services to aerospace industry, but you can contribute to non-aerospace industries. For example, Teflon, the frying pan. It's a the space shuttle as they call it space tiles. Have you heard of
yes.
that? The
Uh,
space tiles is the one that absorbs. It's made from ceramic and Teflon coating. And what it does is when you re-enter into space, um, you have high temperature, very very high temperature. So that is why if you look at space shuttle, you see the nose. What color is the nose? And what color is the undercarriage? You'll see that to be black in color.
Yeah, we black.
The reason is because Teflon coated. They are the heat resistance. They can absorb up to 13, 14,000 kelvins, right? So
Right.
these are the things you can study. And then structure, composite structure, you know, that means lightweight structure. Today's aircraft is made from lightweight structures. Even your cars is made from lightweight structure. Compared to the cars 20 years ago, they are heavyweight. They're very, very heavy, right? But today's cars, if you go and just bang on the side of the door, you will dent it because they don't have any strength to it. It was meant for it, right? So these are the things you can do. Learning aerospace engineering, you can also apply in the ship industry. What is the difference between ship and aircraft?
Uh, a ship is on sea.
In water,
Yeah, in water.
that means you're dealing with density. You're looking at pressure. Same thing happens in the air. There is pressure. There is density, the air density. That's the total difference. So you can apply. Of course, there is also marine studies, marine engineering. In the marine engineering, you learn more towards the ship, water, and so forth. In the aerospace, you learn towards space, into air, and so forth. So there are a lot of classes, 5 years. If you rush through it, you can do it in 4.5 years or 4 years. But normal timeline takes is 5 years. So the first year, you get introduction. You will get introduction how to write reports, projects, and stuff. And then you can, the next 3 years, you do aeronautics engineering. You study everything, right? For example, right, if you become aerospace engineer, you can also work in mechanical engineering because you study mechanical. For the first 2 years, you will study mechanical as well. You can even become a civil engineer because you learn materials, you learn about structure, all that. So only thing is there might be a couple of classes you need to take additional to become a civil engineer. So an aerospace engineer or scientist, you are able to be, you have enough knowledge to work in any engineering field. Of course, electronics, electrical requires you to learn something extra, but you can still apply it also in the field. Have you heard of a new field called mechatronics? It's a combination of mechanical and electronics. It's a deviation from aerospace engineering, right? So an
Yeah.
aerospace engineering field is a pinnacle of engineering, and it's an umbrella that covers many different fields. You need to master all these fields: civil engineering, mechanical engineering, electrical engineering, electronics engineering, computer science, all these fields in order for you to become an aeronautical engineer and then eventually aerospace engineering.
Okay.
So one of the two classes that differentiate between aeronautics and aerospace. One is satellite, the other one is space mechanics. You will learn about space.
Yes.
Okay, so these are only two differentiation between aeronautics and aerospace.
Okay, sir. Okay. Sir, how much is an aerospace engineer paid in Malaysia?
How many? What?
How much is an aerospace engineer paid in Malaysia?
To tell you frankly, there is a very, very limited aerospace engineering company in Malaysia. There are a couple of companies that does aircraft parts for Boeing. We don't have. We do have Angkasa One. We have Malaysian Space Agency and so forth, but we have not done any kind of uh, activities in this area. Most of the activities we have done, uh, we have we have we are supposed to build our own aircraft called Eagle. There's supposed to be another aircraft coming from SMET, but all this was in the pipeline, but nothing came about. When we went to space, about a couple of years ago, all right, joined with Russian cosmonauts. When we came back, we were supposed to introduce this industry in Malaysia. But as per now, the aerospace industry in Malaysia is very limited. Okay, but if you are going to compare yourself in Singapore, Singapore has a very established aerospace industry. Malaysia, we don't have yet. We are still like in a planning stage. Okay, and there is no um, bodies in Malaysia that take seriously this industry to develop this industry further. Nobody. There isn't. Yes, there is two or three organizations, but they are not doing anything in these industries. They just basically becoming a think tank. You know what's a think tank?
Yes.
Ah, they just come up with regulations, formulations, but nothing to do with aerospace engineering, right? But in Singapore, if you're there is a good feel in Singapore. Boeing, McDonnell Douglas, Lockheed, all these major uh, companies are there in Singapore. Eurocopter, we also have Eurocopter, but then we are working through some what is the name of the company? Samsung, not Samsung, Sapura, right? Sapura is one of the companies in the aviation, but they're doing more towards helicopter and aircraft maintenance, all right? So there is no specifically an aerospace company in Malaysia, but if you are comparing the salary, it could be anywhere between you start with something like 12,000, and you can reach up to few hundred thousand if you are senior designer, innovator, creator. You can go up to that much because that's the kind of rate you get in Singapore. In the US, of course, US you don't need to mention. That is the kind of going rate.
Okay, sir. Yes, sir. Sir, do you have any advice for what future beholds aerospace graduates?
You need to be innovator. You need to think something outside the box, right? And you need to come up with something that will save the humanity. Currently, all the invention that has come about is replacing humanity, right? All in the name of um, they want to
Science.
be the best, they want to greed, they want all the money, right? So we are going into AI. So everyone in the world is going towards AI, right? They want artificial intelligence to do the work. So if AI is going to do all the work for you, then what is the purpose of you and me?
True, sir.
Okay, we will not have nothing to do. Right now, even in the olden days, when you want to navigate from point A to point B, you either read maps and increase your own personal skill how to navigate yourself. But today, you ask Siri, you ask AI, you ask Google to guide you, to give you. So the skill of how to read a map is no longer there,
Yes.
right? Right now, you're just taking instruction: turn left, turn right, go straight, make a U-turn. That's the instruction you're getting. So basically, you're not allowing your intelligence to work. So if you don't use any part of your body effectively, in the next generation, it will become useless,
Yeah,
right?
in the future generation, there will be so many AI doing all your work until it's like in the movie. I forgot, I think it's a Disney movie where all the humans in the future become lazy and the robots are doing work for them.
Yes, iRobot,
Yeah.
Matrix. Matrix is a clear example. What happens? What is the need for humans in the future? They're basically harvested for their energy. Your brain produces enough energy to power an entire neighborhood. The electrical impulses inside your body. So the robots one day will take. The iRobot was the first movie before Matrix, but it came later than Matrix. But the gist of the story is the robot will take over the humans, and the humans do nothing but just follow instruction, or just lay there to produce electricity so that the robots can live. So this is the way of the new future. So as an engineer, you need to be ethical, as well as uh, you need to have uh, the human race, humanity at heart. Remember, that is the reason. The earlier generations, engineers before me and before my grandfathers, you can say, our great great grandfathers, when they were inventing things like Albert Einstein, Thomas Alva Edison, Microsoft, Bill Gates, as later as Apple, Steve Jobs, all these people, when they were creating things, they were creating to enhance the quality of life. But today's creation, Facebook onwards, Insta onwards, it is not to increase the quality of life, but to control your quality of life by somebody else so that they can become rich. So as a graduate of aerospace engineering, it is be great if you can bring back that importance. The first engineers who invented the steam engine and the industrial revolution one, they created industrial revolution to for producing things in masses so that it can meet the demand. But today, the demand is not there, the supply is not there, but we are living every day uh, like a robot. We're letting AI take over us. So as an aerospace engineer, it will be great the future generation can realize this and can learn to live without AI, create things that we are still in control, right? If we don't, we creating AI related equipments or technology. Very soon, you don't need to worry about studying aerospace engineering, because a robot will study aerospace engineering and they will do things, and we have no point to work in this. So a lot of jobs have disappeared because of AI. For example, when we invented driverless cars, a lot of chauffeurs and drivers who are driving buses and cabs are no longer have a job. So what happens to them? You see, so we need to be responsible, accountable engineers. When we create something, we have to make sure it doesn't kill the human race, but in fact it improves and enhances the quality of life of the human race. That is the thing that every new graduates needs to understand, because now every graduate who comes out of the industry, they want to create something that can make them millions of ringgit, thousands and thousands of US dollars. They want to get their innovator badge and all this stuff. But what's the point when you will not be living to enjoy them too long, because the AI will be enjoying them later. Yes, you might make millions in a short run, but in a long run, you don't have a life. So we need to be responsible engineers coming from aerospace engineering, because it is the pinnacle of all engineering. This is where innovation and creation happens, right? So we need to be responsible, accountable, make sure whatever we do not destroy the human race.
Okay, sir. Okay, thank you, sir. Last of all, thank you for spending a valuable time in giving us this interview, and it would be much appreciated.
I'm
Thank you
really
again,
appreciative.
sir.
Yeah. Thank you
Thank you
for
again,
giving me this
sir.
opportunity. All the best to you.
Okay. Thank you, sir. Good night.
Okay. Good night.